new. Fine. So here are certain problems are given to you and that are basically on the basis of the knowledge which I gave you earlier, right? And these kind of problems already we have finished, right? We have done, isn't it? It's not new for you or it's new. Tell me, is it new? Is it new for you? Not able to hear anything from you. Will you please speak up? Preetam just showing thumb. What about just one?
Ma'am,
Okay, fine.
we do again.
See the problem, what has happened to you first. See the problem. This is your textbook problem, textual problem, you can say. And this is completely on the basis of knowledge what you have gained earlier, right? So it's not new for you. So the problem is calculate the amount of water, okay, gram produced by the combustion of 16 gram of methane. Correct? Yes or no? Will you please write down this problem? Or else I'll do one. Note down this problem. You dictate me. So I'll do one thing. How to solve it. The book directly. Fine. Have you noted down this problem? This one. Calculate the amount of water. That amount you have to calculate in a gram. Produced by the combustion of 16 gram of methane. What is the methane? Formula of methane is CH4. Correct? Yes? So you have to write down the balance equation for the CH4. Normally what we know, when like any hydrocarbon, CH4, burn in presence of oxygen, it will form what? Two products. First would be a carbon dioxide, another would be what? Water. And with the help, means in this reaction, tremendous amount of energy would be released. And that energy will be in the form of either heat or light. Correct? Now, check whether it's a balance equation or not. You need to balance it first and then only we can do the further process. Now you can check over here. Number of hydrogens are 4 and the number of hydrogens are 2. To balance it, we are going to multiply it by 2. Correct? Yes? So your hydrogen become 4, but then your oxygen here it become 2 and this side it would be 2. So 2 plus 2 would be what? 4. Correct? Yes? And to make it 4, you have to multiply this oxygen by 2. So your balance equation is given here like this. CH4 in a gaseous state plus twice O2 in a gaseous state gives you carbon dioxide in a gaseous state plus water molecule, and that also would be in a gaseous state. Isn't it? Yeah?
Yes, ma'am.
Oh my God. After that, you have to calculate the molecular mass of each, right? What would be the molecular mass for the methane molecule? For the carbon, it will be 12. And for the hydrogen,
16.
one hydrogen has the atomic mass 1, so 4. Total, it would be 16. Correct? So what is given here? 16 gram of methane correspond to 1 mole. Correct? From the above equation, 1 mole of methane will give us what? 2 moles of water molecule. See, you can check it in the balance equation. 1 mole of methane will give us how many? 2 moles of water molecule. Yes?
Yes, ma'am.
Because of that, what we are going to do? 2 moles of water is equal to what? 2 into 2 plus 16. Why we have done this? Because 1 mole of methane will give us what? 2 moles of water molecule. Understood? And because of that, 2 moles of water, how you're going to calculate? It is equal to 2 into 2 plus 16. Clear? So 2 into 18 because 16 plus 2 is equal to 18 and 18 to the 36 gram. So the water you will get that will be 36 gram. Now you have to calculate the number of moles of water molecule. And the water molecule's molecular formula is H2O. Its molar mass would be what? 2 plus 16, which is equal to 18 gram. Right? So 1 mole of water is equal to 18 gram of H2O, which is equal to 18 gram of H2O divided by 1 mole of H2O. That is equal to 1 because 1 mole of H2O is nothing but what? 18 gram because it's a gram molar mass. Okay. And hence 2 mole of H2O would be 18 gram of H2O upon again 1 mole of H2O multiplied by 2. You will get what? 2 into 18, that is equal to 36 gram of H2O. So the water which we have calculated in a gram, that will be what? 36. Answer is what? 36 gram. Very simple. Orally also you can calculate it. I'll do one thing. I'll show you how you have to solve this. Shall I stop sharing the screen? Yeah, I'll share the whiteboard. Is it visible to you? Yeah.
Yes, ma'am.
Okay. Come on, do me a favor. Dictate me the problem.
Calculate the amount of water produced by the combustion of 16 gram of methane.
Wait a minute. Calculate.
The amount of water produced by the combustion of 16 gram of methane.
Amount of water in gram, right?
Water produced
Hmm.
by
When?
the combustion of
Sorry. By the combustion of
16 gram of methane.
how many?
16. 16.
Wait a minute. 16, 1 6.
Yeah,
16 gram of
methane.
methane. Right? Burn, no?
Yeah.
Correct? Okay. So the reaction for that already we have seen, that is CH4 plus O2. You will get what? CO2
C2 plus 2H2.
2O plus energy, correct? So balancing already we have done here 2H2O, right? And then here it will be what? 2O2,
2O2.
correct? Yes.
Yes.
So this is in gaseous state, this is also in gaseous state, this is also in gaseous state, this is also in gas. This is what 1 mole of methane gives you what? 2 moles of water. Correct?
Yes,
Yes or
ma'am.
no? Yeah. So its molar mass already you have calculated. That is what? 12 plus 4 is equal to 16 gram.
16 gram.
Yes. Isn't it?
Yes, ma'am.
Yeah. Now here 1 mole of water is equal to what? 18 gram we know. But then how many moles are here? 2. So 2 into 18. So in problem, in balance equation itself, you will get to know. See, calculate the amount of water in a gram when by the combustion of 16 gram of CH4 burns. When you burn the 16 gram of CH4, what would be the grams water would be evolved or released. So that answer is here itself. You can see here it's a 16 gram of methane. Okay, that is nothing but 1 mole. Okay, it will be produced what? 2 moles of water, that is equal to 18 into 2, which is equal to 36 gram. That's it. Such a simple answer. No need to go into complication. Understood? Already we have learned the stoichiometric problems, right? Stoichiometric relations. So this is a problem related to mole and mole concepts. Clear? Simple? Yeah?
Yes, ma'am.
Yeah. Now, if you want to note down, please note down, or else I'll go to the next problem. Shall I stop sharing?
Okay.
If you want, you can take a screenshot.
Okay.
Fine. So we'll go again for the PDF. See what is given to you in this second problem. how many moles of methane are required to produce 22 gram of carbon dioxide in a gaseous state after combustion? Write down the problem.
How many?
How many moles of methane?
Okay.
This
How many? Are required to produce
this one. Okay.
22
Are
grams
required
produce 22 grams CO2 after combustion.
to produce 22 gram of carbon dioxide. Twenty-two gram of carbon dioxide. Fine.
Yes.
How many moles of methane are required? Shall I go for the again whiteboard? Will you take me the same problem?
Yes, ma'am.
Okay, fine. So we'll go to the whiteboard and we are going to solve it. Let's see what could be the problem. I'll just erase all these things. Fine. Come on, dictate how many moles are required. How many moles of methane
Yes, ma'am.
is required to
To
produce
produce 22 grams of CO2.
22 gram of carbon dioxide, correct?
Yes. After combustion.
Yeah, in gaseous state, correct?
Yes.
Fine. So equation would be the same. That is what CH4 plus O2. You will get what here? Carbon dioxide, 2 moles of H2O plus energy or heat, right? And here it will be 2O2. It is in gaseous state. It is in gaseous state. It is also in gaseous state. It is also in gaseous state. Now, what you come to know here? 1 mole of methane will produce what? 1 mole of carbon dioxide. Correct? Yes? So 1 mole of methane is nothing but what? 16 gram of methane. But then we don't have to have any sort of concern about the grams over here. They didn't ask you to calculate grams. They asked you to calculate the number of moles. How many moles are required of methane to produce 22 gram of
0.5.
carbon dioxide? Yeah. So here what they said, 1 mole of methane is produced what? 1 mole of carbon dioxide. 1 mole of carbon dioxide means what? 2 into 2 carbon, sorry, 1 carbon. I'm sorry, it would be a 1 carbon. Okay, it won't be 2, it would be 1 carbon. 1 carbon plus 2 oxygen. Their atomic masses sum you need to do over here. That is 1 into 12 plus 2 into 32, sorry, 16. That is equal to what? 12 plus 16 is equal to, sorry, 32. I'm sorry, what is happening? Okay, that will be what? 44. Correct? Yeah?
Yes, ma'am.
Yeah. So 44 what? 44 grams. If you express, if you are expressing molecular weight, that would be AMU. If you are expressing it in a gram, it becomes gram molar mass. Correct? Yes? Yeah. Now, how much quantity you need to produce? How much quantity of carbon dioxide you have to produce? 22 gram. This is what? 44 gram. If you have to convert into, like 22 gram, you have to divide it by 2. Correct? Yes or no?
Yes. Yes.
So this 44 divided by 2, you will get 22 gram. Right? Means 1
Yes.
mole will convert into half mole. Right? And what we know, 1 mole would produce 1 mole of carbon dioxide. So obviously half mole of methane will produce half mole of carbon dioxide. Means for the production of 22 gram of carbon dioxide, you require half mole of methane, or you have to burn half mole of methane in the presence of oxygen. Or else instead of, you can say like you have to burn 0.5 moles of methane to produce 22 grams of carbon dioxide. Clear?
Yes, ma'am.
Yeah. Any doubt? Any doubt?
No, ma'am.
Just one. He hardly speaks.
Oh, ma'am. No doubts.
No, fine. Easy? Only I have to babble. Yes, no, nothing. Fine, no issue. Okay. If you want to note down, you can, or else I'm gonna delete. Shall I? Shall I clear the screen?
Yes, ma'am.
Fine. Now we are going to go for the next problem, which is given to you in your textbook. Let's see what it is exactly. Yeah. This will be the problem. Please write down 50 of N2 gaseous state and 10 kg of H2 in gaseous state are mixed to produce NH3 gas, means ammonia. Calculate the amount of ammonia gas formed. Identify. Identify the limiting reagent in the production of NH3 in this situation. Can you do this?
How many?
Please note down this problem first.
Calculate the amount of energy.
Yeah. Wait a minute. I'll let you know what exactly you have to. This problem you need to note down. Please note down it.
Calculate the amount of energy.
50 kilogram of N2 gas, nitrogen gas, and 10 kilogram of H2 gas, means hydrogen gas, are mixed to produce NH3 gas, ammonia gas. Calculate the amount of NH3 in a gram formed and identify the limiting reagent. And identify the limiting reagent. Note?
Yes.
Yes, noted or not?
Yes, ma'am.
Done?
Yes, ma'am.
Done, ma'am.
Yeah. Okay, I'm not able to take it. Check this reaction, which is given to you. This reaction already we have seen, isn't it? Yes or no? N2 plus H2 will give you what? NH3. It's a reversible reaction. In a both way, it is possible, right? See, this is the reaction which is given to you. N2 mixed with hydrogen gas, nitrogen is mixed with hydrogen gas, you will get the NH3 in gaseous state. Fine. Now,
Yes, ma'am.
what we are going to do, we are going to calculate the number of moles for each. Nitrogen given mass is there, hydrogen's given mass is there. And what we come to know, 1 mole of nitrogen will give you how much? 2 moles of ammonia. Correct? Yes or no? By reaction, what you come to know? 1 mole of nitrogen will produce 2 moles of ammonia. Isn't it? See, this is 1 mole of nitrogen gas and this is 2 moles of ammonia gas. Yeah? Now, number of moles of N2 would be how much? They have given the 50 kg of N2. Isn't it? They have given what? Kg. So 100 gram of N2 upon 1 kg into 1 mole of N2 upon 28.0. They have calculated the moles. Why? Because this value is given into what? Kilogram. So, yes? Understanding?
Yes.
Yes or no? Why
Yes,
it is
ma'am.
multiplied by the 100? Because this value is given into kg. Okay.
Why is it the 2.016 gram of it?
0 point?
2.016 gram of it?
Yes, but then calculation is showing over here.
Or the what was it to by?
Wait a minute. I'll just switch off my ceiling fan, and because of that, I'm not able to hear you. Give me a while. Yeah, come on. Speak up now. What you said?
Now I understood about it. Like, why is it for H2 2.01?
Yeah. Understood, no?
Yes, ma'am.
Hello. Yeah. And this is for H2, right? Because mass of hydrogen gas molecule, that would be 2.016, right?
Hmm.
Yeah. So these are the calculations. These are the number of moles for hydrogen. These are the number of moles for hydrogen. And according to the above equation, what they said, N2 require how many? 3 moles of hydrogen for the reaction. And hence, 17.86 into 10 raised to 2 moles of N2. The moles of H2 grams required would be, H2 would require how much? That need to be multiplied by 3. 3 moles of H2 upon 1 mole of N2. See here, this calculation is done. Understood? 17.86 into 10 raised to 2 moles N2 into 3 moles of H2 upon 1 moles of N2. And you will get this much amount of hydrogen. 5.36 into 10 raised to 3 moles of H2. Okay. But then moles of H2, which we have with us, that would be 4.96 into 10 raised to 3. Isn't it? Yes. So it is less. Yeah. And hence, your limiting reagent would be what? Dihydrogen. Come on, tell me. What would be the limiting reagent?
Nitrogen.
Reagent in this case would be ammonia. No, would be nitrogen, because value of hydrogen doesn't match. Clear?
Yes, ma'am.
Yeah, this type of problem already we have solved. Solved or not?
Yes, ma'am.
Why you're facing difficulty then? Yeah, and amount of NH3 produced would be how much? Check it. Amount of NH3 would be produced what? See? Dihydrogen is a limiting reagent in this case, because value of hydrogen is less than that of the X, but we have a 4.96 into 10 raised to 3 moles H2. Hence, dihydrogen is the limiting reagent in this case. So NH3 gases would be formed only from the amount of available dihydrogen, 4.96 into 10 raised to 3 moles. Since 3 moles of H2 gases gives 2 moles of ammonium. Okay. So 4.96 into 10 raised to 3 moles of hydrogen multiplies with 2 moles of ammonia upon 3 moles of hydrogen. So values you need to put and you'll get the value. So you'll get what? 3.30 grams or 3.30 into 10 raised to 3 moles NH3 in this case. Okay. Yes.
Yes.
Speak of something at least. Speak something. Nobody is ready. Fine. Now, one more important concept is there, which is remain in this chapter, which I wanted to explain you. That would be, I think, mass percent already we have seen. A simple problem is given on this mass, that is the mass of solute upon mass of solution into 100. It's a mass percent in a different way. It's related to the solution. Okay. So one problem is given to you on the basis of this, that is a solution is prepared by adding 2 grams of substance A to the 18 gram of water. Calculate the mass percent of solute. How are you going to calculate it? How are you going to do this?
Mass by solute by mass by solute.
Yes. Mass percentage is mass of one substance upon mass of like solute, mass of solute upon mass of solution into 100. But then when mass of solution comes, that time please keep it in your mind, mass of solution is equal to mass of solute plus mass of solvent. Okay, mass of solution means what? Solution is formed by the mass of solute plus solvent. Okay, means suppose I have made one solution with salt and water. Okay, if salt is of 4 gram and water is of 20 gram, right? So my mass of solute would be 4 gram only. But then mass of solution would be 4 plus 20, that will be 24 gram. Understanding?
Yes, ma'am.
Okay. So mass percentage of any like solute in the solution when you calculate, that time mass of that particular substance upon mass of solution into 100, where mass of solution is nothing but mass of solute plus mass of solvent. Understanding? Means both the mixture. Okay. So what is here? 2 gram of your solute A, 2 gram A plus 18 gram of water into 100. So 2 upon 20, that is multiplied by 100. You will get what? This would be what? 1 by 10. 1 by 10 into 100, that is equal to 10%. Understood? Yes? Yes?
Yes, ma'am.
Because it's very important. Actually, you should speak. In other classes, you won't speak a what? Huh? At all? Yes, come on, tell me at that also you're not ready to speak.
Yes,
Dhananjay, sometime he will be present, sometime he would be like absent. Dhananjay, what happened? What's wrong with you? Why are you absent most of the time? Dhananjay, I'm asking you.
Yes, ma'am.
Yeah, why you are absent most of the time? Because I have seen number of times you are not present in the class.
Ma'am, I was
What's wrong
only
with you?
absent on the starting 3 to 4 classes. That's it. I was present all the
The
time.
last period also you were not there. Only both the Jaswant and Preetham was there.
I was present last.
Ask, you can ask them. If I won't lie, why should I lie, isn't it? I have a
Yeah.
concern with you all student. Like if I'm teaching something, you should be present, right? And if you won't be present, you means lose your link, isn't it? Means
Yes.
because concepts are interlinked with each other. That is the reason I'm asking you to attend regularly. Fine, no issues. About the mole fraction, now we are going to see. What is the mole fraction? See, it is the ratio of number of moles of a particular component to the total number of moles of the solution. This is one of the important point which I haven't explained you, right? Isn't it? But then it's really very important in your numericals, you have to use it. If you want to note down, you can, at least you can note down this expression or this formulas. Okay. It is the ratio of number of moles of a particular component to the total number of moles of the solution. If a substance A dissolve in a substance B and their number of moles are Na and Nb respectively, then the mole fraction of A and B are given as. Now see, mole fraction of A is equal to what? Number of moles of A upon number of moles of solution. Means what does it mean? Number of moles of A plus number of moles of B. Like Na upon Na plus Nb, right? And mole fraction of B means what? Number of moles of B upon number of moles of solutions. Solution again consists a mixture, that is Na plus Nb. Correct? Means Nb upon Na plus Nb. Clear? Clear?
Yes, ma'am.
Yes, understood? Fine. Now see the next. Molarity. This is also one of the new concept, right? molality, there are the two different concepts, and what is the basic difference that we are going to see soon. Fine. If you want to note down about the molarity, please note it down. It's important. It is the most widely used unit and is denoted by capital M. How do, like with which letter it would be denoted? With a capital M, right? So here is a definition for the molarity. Most of the time in your board examination, it may ask for 1 mark, or like maybe a combined question would ask. That time you have to write the answer. I know that immediately you're not preparing for the boards. You're means like you want to gain advanced knowledge, but then if you know the definition, you can apply it anywhere. So it is defined as number of moles of the solute in 1 liter of solution. What does it mean? Number of moles of solute in 1 liter of solution. 1 liter solution means how many ml? Come on, tell me. 1 liter of solution means how many ml of solution? Any one of you, 4 students, 3 students are there. Nobody is speaking. 1000 ml, correct? Yes. 1 liter is equal to 1000 milliliter. Now, molarity is equal to number of moles of solute. Suppose A is dissolved into B. Correct. So that time molarity would be what? Number of moles of solute, or A, upon volume of solution in liters. And that should be how much? 1 liter. That should be how much? 1 liter. Understanding? And if it would be 1 liter, then the molarity what? 1 molar. Solution has a molarity 1 molar. Understood? Suppose we have a 1 molar solution of a substance, say NaOH. What is the NaOH? What is the name of this? Sodium hydroxide. NaOH means what? Sodium hydroxide. And we want to prepare a 0.2 molar of solution from it. Understanding? What is given to you? What is given to you? 1 molar of solution of sodium hydroxide. And you have to produce 0.2 molar solution from it. How are you going to do that? How are you going to do that? See, what is given to you? 1 molar NaOH means 1 mole of NaOH present in 1 liter of solution. Understanding? Yes or no? Clear? 1 molar solution means what? 1 mole of sodium hydroxide present in what? 1 liter of solution. Right? Solution. Now, for 0.2 molar solution, we require how many moles? 0.2 moles of NaOH. Correct?
Yes.
That should be dissolved into what? 1 liter of solution. Yes?
Yes.
Clear?
Yes,
yes or no? For that reason, what you're going to do? We have to make 0.2 molar solution from 1 molar solution. We have to take the volume, how much? 1 molar NaOH, which contains 0.2 mole of NaOH, and diluted the solution with water to the 1 liter. Correct? Now, how much volume is concentrated? 1 molar NaOH solution would be taken to convert it into 0.2 molar of NaOH. For that reason, one formula is given to you that you need to utilize. Correct? See what is the formula given to you and how you're going to convert the 1 molar into 0.2 molar. See, here it is. Check this. See. Yeah. Understood? See. Now, how much volume of concentrated 1 molar NaOH solution be taken, which contains 0.2 moles of NaOH, can be calculated as follows. 1 mole is present in 1 liter of or 1000 ml of solution. Then 0.2 moles are present in how much? Right? How much? 1000 ml divided by 1 mole into 0.2 ml solution. That is equal to what? 200 ml solution when you do this calculation. Right? And this 200 ml of 1 molar NaOH is taken and enough water is added to dilute it up to the mark and make it 1 liter in the volumetric flask. Have you ever seen the volumetric flask?
No, ma'am.
Okay, you may see soon once you have started with your 11th grade. Fine. I'll let you know if I have the diagram. Definitely, I'll show you. I'll take the screen up and down and I'll show definitely. It must be there in a chapter because it's some basic concepts of chemistry and those diagram must be given here. Fine. So 200 ml of solution of 1 molar, you're going to take and you're going to dilute it for 1 liter. Correct? You will get what? 0.2 molar NaOH. And here, in fact, for such a calculation, a general formula is given. That would be what? See? This. Please note it down, which is important. This one. M1V1 is equal to M2V2. M1 into V1, which is equal to M2 into V2, where M and V are molarity and the volume respectively. Can be used in this case. M1 is equal to 0.2 M or molar. V1 is equal to 1000 ml. Then M2 is equal to 1 molar and V2 is calculated, means need to be calculated. How much would be the volume, right? So 0.2 molar into 100 ml is equal to 1 molar into V2. So V2 would be how much that we need to calculate, correct? And if you go for the cross multiplication, you will get this is a multiplied 1. It goes that side, it become divided. 0.2 into 1000 divided by 1.0 is equal to 200. Sorry, 200 ml it should be. I'm sorry, it won't be liter. Here it's a printing mistake. It should be ml. Got it? Yeah. Sorry, am I audible? Hello?
Hello.
Ma'am, you're audible.
Am I audible? Okay,
Yes,
fine. Yeah, fine. Understood? Clear?
Hello.
Hello. Fine. Okay, I'll give you a few questions and one more thing. Molality, I have to explain. I have explained only the molarity. I want to explain you about the molality now. It's the same concept, only the differentiation in between what that I explain you. Because in grade 10th, you didn't had that concept. That was completely new. That is completely new, right? Molarity, see, it's given here. Correct? What is this? It's a last concept from your chapter. It is defined as the number of moles of solute present in 1 kilogram of solvent. Understand the basic difference in between your molarity and molality. Yeah? Huh?
Yes, ma'am.
What is the molarity? Molarity, the number of moles of solute present in 1 liter of solvent, correct? That is molarity. Now, molality means what? It is the number of moles of solute present in 1 kg of solvent, right? It is defined as what? Number of moles of solute present in 1 kg of solvent. And it is denoted by small m. Molarity is denoted by capital M and molality is denoted by small m. This is the basic difference in between both. Thus, molality small m is equal to number of moles of solute upon mass of solvent in kilogram. That won't be in liter, it would be in kilogram. Understanding?
Yes,
Means instead of 1000 ml, you have to take here 1000 gram. Clear?
okay, ma'am.
Yes?
Yes, ma'am.
Fine. So I think I have started with the 16. For the 40 minutes, it will be by 7, it would be end, right? Yeah? By 7. Hello, I'm asking you something.
Ma'am, your voice is breaking.
Your voice is breaking.
Am I audible now?
Yes, ma'am.
Fine. So I just wanted to know by 7 our class should end no, for this. It's like as per the timing, 40 minutes timing, our class should be in by 7. So last 4 minutes are remain. Please, if you have any sort of query, any questions, I think only 2 to 3 proportional laws I have to explain. That I'll take it by tomorrow in your class. Your chapter would be done. Fine. And immediately I'm going to start a new chapter and like a few problems on the basis of this molarity and molality concepts I'm going to post maybe by today itself. So you have to solve by tomorrow evening. Okay.
Okay, ma'am.
Okay. Come on, at least show me thumb at least. That is also, that efforts also you're not taking. How come?
Ma'am, I guess you're not able to hear my voice.
Okay, fine. No issues. Okay. Shall I end the class now?
Yes, ma'am. Thank you, ma'am. Have a nice day.
Yeah. Yeah. Hello,